Alright, so welcome back to the OneClass channel. Again, my name is Joey. I'm going to be your chemistry teacher for the next hour. So here at OneClass, if you're tuning in for the first time, we are kind of in this process of verifying solutions for frequently asked questions in chemistry and the mathematics, both in the secondary level as well as in the university and the college level. So based on those, we basically compiled a bunch of math and chemistry questions that are basically sent in by you folks at home, and I've organized these questions in a series of 10 so that we can answer kind of within this hour we can try to answer 10 questions about chemistry or about math, and that we can hopefully verify the solutions, and I can teach you the concepts behind those solutions as well. So my name is Joey. I'm currently a secondary school educator in Ontario. My teachables are currently chemistry and music. However, I'm planning to get my math teachable very shortly in the summer as well. So without further ado, let's get started on these problems here. So we have our first problem here is draw the major product formed in the following reaction. So classic organic chemistry question here. So what we're going to do is we are going to I have here an epoxide. So epoxide, if you recall, it's kind of an oxygen here, and it's kind of it's cyclopropane with the oxygen here. It's not, again, it's not. I didn't draw it really nicely here, but this here is an epoxide, and then I have this kind of ethyl chain here. I'm going to react it with sodium cyanide, and it's going to be an ethanol and in water as well as our solvent here. So what would that do to our epoxide here? So what's going to happen is basically two things could happen here. When we look at here, this here is an epoxide. So when we talk about epoxide here, we can talk about, there's two kinds of epoxides here. So there's symmetrical epoxides and there's asymmetrical or unsymmetrical epoxides. And all you have to do is kind of look at these side groups here. So in this case, we have this group here, which is simply just hydrogens, and this group here is the ethyl group, right? So as you can see, if both of these groups don't match, then this is a asymmetrical or unsymmetrical asymmetrical epoxide here. And this is important when we talk about especially ring opening epoxide kind of reactions here. So if we have an asymmetrical kind of epoxide here, basically one of two things could happen. Basically every time you have, if you're reacting it with acid or base conditions here, it's going to open up a ring. So we know that this here is going to be a ring opening reaction. And what it's going to do, but how the mechanism behind this is different if it's for an acid or a base. So looking at this guy here, we have sodium cyanide here is a very, very strong it's not very strong, but it's a basic condition, right? We know that this here, sodium cyanide here is NaCN. I can add it with H2O, and this would be in equilibrium with, we have just simply the sodium ion here, and we have the HCN here. So this here, and then obviously plus with water here. And HCN here is this is a very, very strong conjugate base here, hydrogen cyanide. So this here, it makes it a basic condition. So basically what we'll have is a basic condition, right? So I have NaCN, and what it's going to do in general, if I had a basic condition, conditions such as sodium hydroxide, sodium cyanide, for example, it's going to basically attack the least substituted ring. So it's going to open through. It's going to attack this least substituted ring. So how I'm going to illustrate for that for you. Let me just erase these lines here. And how it's going to do that, again, I have this negatively charged cyanide group here. And again, as you know, my lone pairs here are drawing a partial negative charge here, which means these guys here are both partial positive. Now, this is the mystery of to solve. Is it going to attack the left side or the right side? And we know that in organic chemistry, if it's a basic condition, it's actually going to attack the least substituted member. So in this case, it's this guy here. So this guy here is going to come, attack here, and then break up this oxygen, break up the epoxide here. I'll do some black for you. Just come here, attack this carbon, and it's going to break up this epoxide here. This is SN2 reaction. It's done in one step here. And then all I'm going to be left with is I'm going to be left with an OH or HO hydroxide group on this left-hand side. And then I'm going to have 1, 2, and then, so this here is carbon, this here is carbon, here is carbon 1, this here is 2, and then I have obviously 3 and 4, right? And this here will be my hydroxide for, this here would be my product for this ring opening here. So let's see here. Oh, I forgot the CN, my bad. So the CN is going to come attack here. It's a nucleophilic SN2 substitution. Sorry, this here is an NC, my bad, because I have the sodium, cyanide attacking here. And then I'm going to get, so it's going to be a CN here, and then it's going to be, there's going to be an O here as well. So this here will be O. So 1, 2, 3, 4. I have 1, 2, 3, 4. So this would be on carbon 2 here. So here's OHO. So 1, 2, 3, 4 here. So the solution here is correct. Again, 1, 2, 3, 4. 1, 2, 3, 4. Again, this is bonded to the cyanide group here, and then carbon 2 is bonded to the hydroxide group here. So you could think of this as, this here is carbon 1 because it's being attacked here. This here is carbon 1. Carbon 1. Carbon 2 would be bonded to the hydroxide group here, and then also bonded to the ethyl group here, which is this ethyl. Ethyl is here, and this ethyl is here as well. So this solution here is correct. As you can see, the basic condition is going to attack the least substituted guy, so you're going to get this as your product here. If it was an acidic condition such as HCl, it's actually going to attack this partial positive and the most substituted one, and it's going to bring opening. It's going to do a ring opening from that. In this case, the stereochemistry doesn't matter because I didn't have doesn't say show stereochemistry, or it didn't show me if it was sticking up, if it was a wedge or a dashed diagram here. So if it does, though, again, you could if it takes place here, you have inversion here of stereochemistry, right? So that's kind of just a little bit about stereochemistry here. So solution here is correct. Good analysis here because I like how they provide analysis as to the ring opening of epoxides in both an acidic and a basic condition here. So solution here